No voicemails. It was so annoying. You're going to call me and it's important to leave a voicemail, otherwise don't call me. Anyway. Those telemarketers.
And I get along too.
Okay, number 81. Someone have a defense for the answer that they think is right. They're willing to defend, argue their answer. Sean, what do you think it is first?
C.
C, okay. He thinks it's C. Why? I'm just writing the C because that's what we got.
Because when we're talking about continuity, it means that it's like the function actually flows.
Mm-hmm.
So in the sense that if x equals 0, and then we're moving up 1 and then minus x, the next, if we go like even just a smidge outside of that, we're already up at y equals a little less than 1. So like plot is 0, like 0, 0, because that's where it's going to be. And then even if we move all the way, like just like a little bit to the right, we're all the way back up.
Because if you plug in 0,
no, it's a hole. Well, not a hole. It exists, but it's not on the line.
Good. The function is not continuous because he was trying to describe the idea, because he was like, if I plug in 0.1, I'm way up by 1. If I plug in 0.2, 0.3. But another way of looking at it is plug in 0 and say, okay, it goes all the way to it, but not at it. Remember? You can plug in 0 and put a hole and then do your little line. But he was seeing, like, to go from here to there, yeah, there's no continuous flow to that. There's no connection to that. So this line's going da-da-da-da-da-da-da, boom. No, that's not continuous. And remember, hold on, pause. Which is false. Some of you guys might have been looking for which is true. The false statement, he is correct. The function is not continuous because of that check.
So why is f of 0 equals f of 1?
F of 0 is equal to f of 1.
B.
Oh, because f of 1, they're the same. So what you were thinking, I think, is at 0, 1, f of 0 equals 0. And the limit as x approaches 0 is 1. But they were saying f of 1. So just plug in 1. 1 minus 1 is 0. Yeah, 0. Yeah. Yeah. Any other confusions? Differentiable? No sharp points or no discontinuities within. There is at 0, but at 0 it's not included for differentiability, so that's okay. Plug in 0, it's 0. Plug in 1. 1 minus 1 is 0. Those are true. And the derivative is never equal to 0 on the interval. If you look at the line, yeah, the slope's always negative. But if you take the derivative of the function, the derivative is negative 1, not 0. So that's not going to work. Number 82, who has an answer and is willing to defend it?
Oh, let me flip to
I'm willing to defend.
Okay, Charlotte, go ahead. What answer do you think it is?
The number 4.
Okay, so D.
Yeah.
Good. And then why? What did you do?
I just use a formula that f prime plus c
Good.
equal f d minus f a is b.
And who's B and A?
Is 2 and 0.
Good. And when you solved, what did you get this whole side to equal?
0.
Good. And then what did you get as the derivative?
3c squared minus 4.
Good. Guys, do you see how the 0 is just waiting for you to choose it after doing f of b minus f of L or b minus a? But can you choose just the 0? Who are you solving for? So you got to plug in the derivative. So then, hopefully, just with some quick algebra, adding 4, dividing by 3. Charlotte already said square root of 4 is 2. My question, plus or minus? No, they were nice. They didn't put plus or minus. 2 over root 3. They could have. But why is it just the positive one? Good. In the interval, you only keep the positive one. So just the positive one is the final answer. So do you guys agree with her?
Yes.
I do too. Wait, does MBT exist? Or, sorry, can MBT be applied? Is the function continuous? Yes, it's just a... Is he differentiable? Yeah, no sharp points and jumps or jumps. And the derivatives. Number 83. Who has an answer and a defense? Nathan.
Okay, I'm going to say D.
Why?
Because for all the other ones, I couldn't find any continuity breaks or or like sharp points, or
But what about that one? Isn't he
but
discontinuous?
he's outside of the interval.
Good. It'd be 3 outside of the interval, so he's okay. And when you take the derivative, the only problem is at 3 again, so it's okay.
And then for the top one,
Uh-huh.
it's continuous still because even if you plug in -1, it's a
Yeah.
fifth root. So
It's a
it's,
fifth root, so negatives and positives, so it is continuous.
yeah. But then if it's differential line, then we talk about that. But it doesn't.
How do we check differentiability?
I don't remember.
What's the domain restriction?
Wait,
just derived it. I literally just derived it in my head, and I was like, so
Maybe
it'd be
one
1
So
over.
A's derivative would be putting down the 1/5, right?
Yeah.
Yes.
So.
And would it then be to the negative 4/5?
Yeah.
So it can't be 0.
Did you finish this?
Oh, music that real quick. Okay.
Oh, I think it was 0 in the bottom.
So it's not differentiable at 0.
It's not differentiable at 0.
So it's
So what does that mean?
So,
It's A.
how about
Oh, we'll go look at the other ones. But first of all, does it make sense why A does not work?
Because it says 0,
It
right?
is continuous. You can't plug in anything to the fifth root. That's totally true. But when you take the derivative, now you have a negative exponent. Good take it, yes.
So
It's continuous, but why is it not differentiable? Well, the derivative won't exist when x equals 0. See it?
yeah.
So since the derivative is discontinuous
Is
at
it a
0, that
vertical-
means the derivative won't exist when x equals 0, which means the function is not differentiable.
Is it a vertical tangent?
vertical.
It would be, the derivative would have a vertical asymptote, which means it would be a vertical tangent line, which means the fifth root, you guys remember what the cubed root looks like?
Mhm.
Fifth root's going to be very similar, a vertical tangent line at 0. That's why the derivative does not exist. The derivative will actually be one of these numbers.
Oh, that's the other things.
Okay, let me read the notes, right? Okay. Somebody was asking though, why not D? Why not D, kiddos? Is D continuous?
Yeah.
Yeah, just x has to be greater than or equal to -1, which is okay on the interval. What about the derivative? Doesn't he also have the problem of bringing down the 1/2 and getting a -1/2? Wait, the derivative won't exist at -1, so isn't that
But
That's the
but it's on the open.
differentiable on the open interval? So it's differentiable everywhere but -1, and so we can say that it's differentiable on the open interval. That's true.
I mean, like the continuous, so it's x.
Oh, you can plug in -1. Square root of 0 is 0. So the domain
X bigger than -1, right?
or equal to. Square root of 0 is 0. That's okay. That's okay. Yeah, not a denominator. And then our cosine, you guys might have been a little bit confused. If we had gone ahead and looked at the derivative, he's very similar because it would be, you'd have to do second d first and first d second. So in part of it, you would have had a square root of 1 minus x squared. But once again, the discontinuities would have been x can't equal plus or minus 1. But I don't have to worry about that because differentiable is on the open interval. Our cosine itself is continuous. The x's of the original are the y's of the inverse. Oh, I know what you're talking about. Tyler, talking about the domain restrictions.
Should be 8 for sure.
You can plug anything into our cosine. The range is what's restricted, but the x's, our cosine, is continuous everywhere except. I don't know if you can see it. X is going to be within -1 to 1 for our cosine because our cosine says, give me some cosine values, I'll give you an angle. But what values can cosine equal between -1 and 1? You guys could go look at the inverse trig section where we wrote down the graphs. But the x's of our cosine are in between -1 and 1, so it's continuous. And it's not differentiable, but it's at the endpoints, which is okay because of the open interval. So hence why you get whoosh, whoosh. But guys, look at this. Wasn't this one fairly easy to see it's continuous because it's a fifth root, so there's no problems. Only even roots are problems. And then its derivative, wasn't it fairly easy to see x can equal 0? So they gave you more functions, but technically, you could have started with the easy one and you ended up, that's sometimes how the AP goes. Not always, I don't want you guys, but educated guess. If you're talking about not differentiable, if you take a derivative and it gets a negative exponent, we got to watch out for any of the ones with negative exponents. You could have done every single derivative and looked at them all. Maybe you just take them one at a time and either they pass or they fail, or you're not quite sure, and you move the question mark and then you do a 50-50 guess at the end. But, yeah, the final answer should have been?
Hey.
But B, like, it's possible. Like, it could have, if it had been like -2, then we would have been in trouble. I'm so sorry, Caitlin, I'm just holding on to this. Kiddos, let's go ahead and grade our 3.2. Any quick questions, though, before we go off the page that we didn't get to answer? Okay, good job. On our calendar, I did have today as being like a AP practice day. Because of our schedule and trying to fit in a Chapter 3A test before Thanksgiving, I'm not going to go into tons of depth on that as far as doing more multiple choice practice on MDT. You might have like a little AP packet with AP type questions over the break that you try multiple choice questions. So that's what that would be like bring in. Where I bring in those multiple choice that I did want to go over today. There's actually like a whole homework assignment, but we're just going to keep on going for sake of time. Can I borrow your blue pen? I just noticed it was missing. Okay, is there any other missing grades online? Check web. I have until Tuesday afternoon, evening, to make sure that everything is good. So I'm going to be working on grading tests and whatnot this weekend. Your last test, depending on how it is, it might not go on this grading period. That's why I've been working, if you're wondering why you haven't gotten your test back, well, David needs to finish taking it. But also, Dave, with soccer and with him not being able to get out of other classes to come in, and then we had lots of shorter days. Long story short, I was getting your bonus back on your last test with the correction. That's what I was focused on, and that has been updated online, but please see if there's any like missing notes or homeworks. My TAs did, I think, forget to write down a few homework packets, and so some weird things are missing, so please check that out.
Do we have the grades for tests?
No, because I haven't. For your last test, I got the bonus in there, that's what I was just explaining.
Oh.
This weekend I'm working on trying to get your other tests, but I might not sneak them in to end the grading period depending on how they work, because it was a hard test to make match. Number 6, kiddos. Final answer is, well, weren't you just trying to make a tangent line? No. Derivative. The wording was a little bit weird, but basically the derivative will equal 0. These are the two intercepts, just set the y equal to 0. What they were trying to do was, hey, the two intercepts, f of b equals f of a, because they're both on the axis. So therefore, take the derivative set equal to 0, it happens at -3. Number 16. Rolls does not apply. Why? X does not equal 0. The function is, not continuous at 0, so therefore rolls does not apply. You can stop. Number 16. Rolls does not apply. Number 22. We just started grading, bud. We'll catch you up. Number 22. If you plug in f of 1 and you plug in f of 3, they are not equal. This one was some nasty, like, logarithmic thingamabob. It's a decimal. If you were to plug it in, f of 1 does not equal f of 3, so rolls does not apply. It is continuous on the interval. Because ln of x just has to be greater than 0. It was continuous. Differentiable, 1 over x, yeah, x can't equal 0, but that's okay. But f of a did not equal f of b on number 22. So, rolls does not apply. Number 48.
Can we just use our calculator for this one?
As far as solving for C? I mean, you could have just stopped at 4 over e minus 3. You didn't have to get a decimal.
How did I like it? Because there was just a lot of wild people doing a lot of wild things.
A lot of wild people and wild things? That's a little crazy.
Wait, so with...
Well, first of all,
Okay.
guys, what's the domain of ln? The argument has to be
It has to be greater
than 0. So x has to be greater than -3. So x has to be greater than -3, which the interval is. So continuous, check. differentiable. When you go to take the derivative, you get this guy down here because of product rule. Be careful, it's a times. First, second, product rule. Second be first plus first be second. They went ahead and took, oh no, they just simplified. X plus 3 over x plus 3 becomes 1, so it made the derivative a little bit easier. But once again, the derivative is fine everywhere x greater than negative 3, which it is, so we're good. So it is continuous, it is differentiable, then MDT, that's all it needs. It says go. So plug in f of b minus f of a over b minus a. It did take some work plugging in. They just left it, Sean, with ln's. This one, though, they were able to make 0 because if you plug in negative 2,
It's 1.
it's ln of 1, and any log of 1 is always 0. Any log of 1 is always 0. So they were able to make it probably even simpler than maybe you even realized. And how on earth did they make 2 ln2 to be ln4?
Because we brought it to the something squared.
Good. The 2 is the power properties. They said, oh, this is the same thing as ln of 2 squared, so ln of 4. Once they found f of b minus f of a over b minus a, they were able to set it equal to f prime of x or f prime of c. They don't make it c, because they're like, whatever, solve for the special x, and that is c. They just name c at the end. We've been putting c up here so you don't forget, either way. But then they went ahead and just said, subtract the 1, take e to the power of both sides.
Wait, so
That's
Wait,
right.
that doesn't.
I don't see how they
How
how they got
use
the
the e
negative
to the
1.
power?
Does this make sense? Derivative
Yes,
equal to
she
f
she
of
makes sense, but the next
Okay.
Yeah.
they did a different property.
So they have the 4 minus 5 to ln 4 and then minus 1. And when you take e to that,
yeah.
it's just x plus 3.
Now here's the
But how do you
struggle.
do that?
This is what they did. This is technically right. You could have done minus 3 at this point, e to the ln of 4, minus 1, minus 3.
You can say this.
Huh?
You can say this.
Well, because there's
The
a
one.
there's minus 1.
Okay.
Close. You're thinking the one-to-one property from pre-cal. That would have been perfect except for the minus 1 because he's not in the ln. Good question, though. That would have made everything so much easier. But that's actually exactly the same reason, David, that you can't just cross off e and ln because of this minus 1. But they didn't write it like this. What on earth did they do? They said when you subtract powers, it's the same thing as
Dividing.
dividing. When you divide like bases, you subtract the powers. So they went ahead and put e to the ln of 4 over e to the 1. What happens to e to the ln now that they're next to each other? They reduce. And we get 4 over e minus 3. Now they also got a common denominator, whatever. They multiplied by e over e. But good question, good question. Technically, if it was a long answer, you guys could have stopped way back here. See that? Box it. Done. Box it, you're done. But since they kept going and to make it match, well, they must have simplified. I do see an ln. Stink power properties, and let's go. So, good job if you had a right answer, but you might just want to show the simplifying because we're practicing making it match, which we all know in the last test was hard. All right.
C6. So well.
56. Okay, so with 56, you were supposed to get a graph of everybody, but to get a graph of everybody, don't you have to get equations for lines? Okay, so equations for lines. Think just y minus y1 equals m times x minus x1, yeah? But for the secant line, we just use the average slope, f of b minus f of a all over b minus a. So for secant lines, we just use the average slope, like the 1/2 of MBT. F of b minus f of a all over b minus a. That's the secant slope, and you can plug into your calculator. They did 1.3863. Or you can keep it the snazzy ln of 4 or 2 ln of 2. And then they plugged in the 0.00. For the tangent line, what do we need?
The inverse.
The
The derivative.
derivative. So they went ahead and took the derivative. Secants ended up canceling, which was really nice, because it's 1 over u times u prime. The secants cancel, but the tangent pi x times pi stayed. They went ahead and had to find the c where that was true, where the tangent line would be parallel to the secant line. So they had to go ahead and take f prime of c, set it equal to the other. They had to solve, and yeah, you're right, Sean, it's nasty. They ended up, because of the tangent inverse, they just got a decimal. And then with that c, that's your x1. They plugged that into the y to be your y1s, and then they were able to plug in. The last step was they had to figure out the derivative, but the derivative was the same thing as what we set it equal to a second ago. That was the whole point, is that it needed to be that element form. So it's nasty. You could have checked it, though, by graphing this guy, graphing this line, graphing that line. You should have seen, hey, there's the slope in between, and there's the parallel slope. That could have been a way of checking it, but there was a lot of nasty math. Guys, this is on the video if you want to check it out with a little more time this weekend. Oh, I thought there was one more. No?
Nope.
Oh, okay. I can leave this up for a couple more seconds then. Do you guys have any questions on the odds? Now, evens, I know. You just saw some of this for the first time. Maybe you need to digest it a little bit more over the weekend. If you missed something, get the right answer down and check it. But the odds you could have checked. You could have CalcABed. Are there any odds? 61. Awesome, we got
Yeah, 61.
61. 61, the nasty one?
I couldn't read.
Okay, let's go peek at 61 really quickly. I'm going to go ahead and minimize this. I have the homework right here. Alright. I have the solution to 61 right here. We'll get back to this in just a second, but let's see what the book said about 61. I think it was a word problem, right?
Yeah.
And like to like explain why
Yeah, it's just like, I just literally just stated what, like,
By using the mean value theory, you can see that with the
The pumpkin farmer yesterday was supposed to help you on 61. The pumpkin farmer yesterday was supposed to help you on 61. Hey guys, MBT, there's a formula, right? F prime of C equals F of B minus F of A all over B minus A. But a quick question. Aren't there also words that go with forever card number 22? What are the words that go with forever card number 22? Any answer, Jeff? Actually, I know it's cool. When I forgot to remind you yesterday, it's also especially if you're taking your test today, that makes sense. Hey kiddos, what are the words for forever card number 22? Has anybody found it in their notes? Yeah, Sean, what do you got? The words.
With a few function that satisfies the following. F is continuous on the interval a of b. F is differentiable on the open interval of ab. So, therefore, then there is a number x equals c within the interval of ab, such that the derivative of c is equal to the average slope of the 2 points.
And the little note I put down below is there's a place when the instantaneous rate equals the average rate. Instantaneous rate derivative equals average rate. What? Oh. It's just the peaches peppers. Oh, I put it away. My fingers are cracking because it's dry. So, looking at this up here. Instantaneous equals average. Instantaneous needs a derivative. Average just needs a change in y over a change in x. Kiddos, who are your variables in this problem?
You have
Temperature and time. You have temperature and time. So when we're thinking about change in over change in, right? Average rate, which is usually dy, well, no, not dy dx, which is usually delta y over delta x, y2 minus y over x2 minus x1. And this one, the average rate is going to be delta temperature over delta time. How did the temperature change? Like yesterday, it was our change in distance over change in time. How far the pumpkin farmer went and what time. We were able to figure out his average rate and said, well, if this average was 75 miles per hour, he was not going under 50 that whole time. He had to go 75, and he had to have gone above. Okay, and this one, what was the change in temperature?
No, 1500
minus 9 through 390.
Yeah, because it started at 1500. Now, the 90 degrees, that's just the environment. Don't get confused by him. He started at 1500. Now he's down to 390, and how much time passed? So I can plug in the 5 hours. And what was the change in degrees? 1,110, is that right?
Yeah.
Okay, so then we divide by 5, and we end up with 225? Hold on. 5 into 11 is 2. 5 into 11 is 2. 5 into...
Would that be 2 to 2?
Two, two.
So what Anna is saying is that you actually subtracted this one from that one, which would be a negative. So is it going to be decreasing at a rate? Yes. By what? By MBT. Kiddos, I did not remind you yesterday to have your FRQs fully attended and graded for today. I'm going to be collecting it on Monday. The answer key is on my class folder handouts.
Oh.
Email me if you can't find it. I'll send you a link.
When we grade
Can you see?
Yeah. So there are 9 little marks possible, 9 points. Make sure your stamp sheets are turned in too. Yeah.
I'm gonna leave my notebook your favorite.
Perfect. TAs will grade it and we will grade it.
I'm not sure my last time.
Okay.